Us humans are really, really good at detecting objects. Even if you were flicking your eyes left and right, the second that you stopped, you would instantly be detecting objects around the room, like your laptops or water bottles. It's why we're so good at things like catching a ball, or maybe finding a friend in a crowd, or even just driving. But if you wanted a self-driving car, you can't just give the car a camera and expect it to work. How will the car know how to differentiate its surroundings? This is where YOLO, or You Only Look Once, comes in. It is a convolutional neural network, or CNN, which, after looking at an image only once, can detect exactly what's in that image and where those objects are. Essentially, it will look for objects around the image and assign bounding boxes around them to help differentiate them from their surroundings. It'll also run an image classification on top of that to figure out what those objects are. And this means that YOLO is the solution to our problem. Given a camera, a computer can detect any objects around it, for example, cars or pedestrians. YOLO is actually surprisingly accurate, and when I approached this problem, I found that there are pre-made data sets for YOLO to detect certain types of objects, which proved very useful. I decided to create a program that can take in an image or video file, and after looking at it once, we'll output another image or video file with all the bounding boxes and image classification attached to it. I found a great video of a suspect getaway on CNN, and I'd like to show you the results. Honestly, the fact that he couldn't even drive his car properly means his getaway was probably failed from the beginning. But either way, how does YOLO work in the first place? Well, YOLO is made up of mostly convolutional layers, which you could think of as running a filter over an image. These layers will be detecting features in the image. So early layers may be detecting simple features like edges or corners. However, later layers in this neural network could detect entire objects, from suitcases to laptops to even entire people. There are also pooling layers, which help lighten the load on the neural network. Pretty much, these pooling layers try to reduce the spatial size of an image while preserving any important features. And they do this in one of two ways. The first way is max pooling, which is basically like splitting the image into a bunch of different sections. And here I've highlighted them in red, blue, green, and yellow. After that, it will take the largest number in each of those sections and assign that as the new brightness value for the resized image. The second is average pooling. And average pooling functions largely the same, except it will take the average of all the numbers in each section and assign that as the new value. And finally, we have the activation layers, which are key to the entire neural network. These activation layers help provide the output for the next layer of the neural network. And YOLO actually uses a type of activation called ReLU. Although it sounds complicated, it is actually pretty simple, as all it really does is remove any negative numbers. What I mean by this is that if the output was originally going to be a negative number, it would have been set to 0, and any number that was 0 or above would have stayed the same. YOLO will also use a linear activation function to make the final prediction at the end. And all of this is meant to help cleanse the data for the next layer of the neural network. So that covers the image classification part of the neural network. But I still haven't talked about how we can figure out where objects are. Well, YOLO does this in a very simple way. First of all, it will split an image into an S by S grid. After it does that, each grid cell will predict a number of bounding boxes. And here I've highlighted their confidence in bold, or how accurate they are. The more bold these bounding boxes are, the more accurate they are, and the more likely there is an object there. After this, it will take the bounding boxes with the highest confidence and then run the image classification on top of those bounding boxes. This means that YOLO doesn't have to look at the image as a whole. It only has to look at the bounding boxes, and it can run the image classification without having to look at anything else. This is why YOLO has so many uses. Like, I've already been talking about how YOLO could be used in self-driving cars, and I'm looking at you, Tesla and Waymo. You could be detecting pedestrians or traffic lights or cars. But there are still thousands of other use cases, and I really want to show you some of them. There are already novel tests being run in recycling facilities using YOLO to help detect recyclables versus trash. 35% of all the stuff we throw in our recycling bins actually doesn't get recycled, mostly because of human error or because some of the stuff we're throwing in our recycling bins aren't recyclable in the first place. Although we have humans in factories already to help throw out some of the trash that gets filtered in with recycling, it is still not foolproof. So I propose using YOLO to detect recyclables versus trash, and using a robot arm to help dispose of any trash while leaving all the recyclables. Of course, there may be a couple problems with this, such as edge cases, like liquids in containers, which may pass by the neural network. However, it would largely automate the recycling process, and we'd only need minimal humans to help catch any stragglers that get through. Another use case would be suspicious activity detection, which is already used in a lot of smart home systems today. Pretty much, you could detect objects or people on your front porch and detect when those objects have been moved or taken away by any particular porch pirate. You could also detect whether there was any movement at some time by comparing the last frame to the current frame and checking how much movement there was. A lot of smart home systems today actually use this movement checking system, but YOLO could also be used to detect exactly what was taken from your porch and when. Another sort of radical but also dystopian idea would be using YOLO for suspect detection. Basically, what this would mean is having a data set of every single person in your city. And after getting that data set, being able to detect each individual person. This could be done in theory, but it may not work in real life just yet. But after YOLO improves, we could possibly do this. But imagine that, catching a criminal that's been like jacking cars or something, or finding a lost child that's been missing for 3 days. The possibilities with this are endless. So that's what YOLO is and what we can use YOLO for. YOLO is today one of the best object detection algorithms we have. And this is rightfully so, because there's still thousands of other use cases I haven't even talked about because of its power. For example, what if you use YOLO in medical imaging to detect different anomalies in medical scans? Or maybe using YOLO to detect logistics of a city, like traffic. Either way, YOLO is very powerful and it has a lot of value and potential. And I hope that I've helped you see that too. Thank you.